When natural coastal defences like beaches, sand dunes and wetlands are not carefully managed, or when they simply can't cope to prevent coastal flooding caused by storms and sea level rise, hard engineering is often a last resort to protect towns and development against coastal flooding.
Here on the North Somerset coastline, catastrophic flooding in 1981 has led to the development of a hard engineering approach. This was paid for by the Environment Agency at a cost of £2 million in the 1990s.
The first line of hard engineering defence against the sea is often riprap or rock armour.
So here we have an example of riprap, a disorganised pile of large, resistant limestone boulders. The idea of these boulders is that they provide a physical barrier between the erosive power of the sea and the easily eroded rocks behind. So the riprap is a rather random and chaotic pile of boulders simply dumped here to prevent the erosion of the cliff. This may look like riprap, but it's actually called rock armour. Rock armour is designed with this gradual slope which reduces the erosive power of the water, preventing processes such as hydraulic action and abrasion attacking the coastline behind. So the rock armour here is dealing with the wave energy, and the flooding is prevented by the seawall at the back.
So the reason this rock armour has been placed here is because this seawall actually has quite a vertical face to it. And we now know that this kind of vertical face can be a design flaw in a seawall. As waves hit the face of the seawall, they're reflected back out onto the beach, and they scour and erode away the beach material in front of the seawall. This can undermine the foundations of a seawall, causing it to collapse, which is why the Dawlish seawall in South Devon collapsed during the winter storms of February 2014. So here, engineers have solved this problem by placing rock armour in front of the seawall, and if we look further down the coast, we can also see how the problem can be solved by changing the design of a seawall. So this is a wave return wall, or a recurved sea wall. Now, when the tide is high, the sea level comes right up to the base of the sea wall, and when the waves are small, they'll lap up the front of the sea wall, losing their energy as the water shallows. But during big winter storms, when we have large destructive waves, the swash of the wave flows up the seawall, and the curve and the lip of the seawall flings it back out towards the sea. The wave then comes splashing down on the sea surface, and this prevents the backwash of the destructive wave from eroding the material on the beach in front of the seawall, which would undermine the structure of this sea defence. This huge recurved sea wall stands over 6 metres over the beach, protecting the whole town of Burnham-on-Sea. It was built following the storms in 1981 that destroyed the old seawall and caused catastrophic flooding in the town. The step slope of the front of the seawall absorbs the wave energy, encouraging the waves to break, and the curved top of the seawall deflects the waves back away from the town. These holes in the front of the seawall also serve an important purpose. If floodwaters ever do overtop the seawall, that water can flow back out to the sea through these carefully designed one-way storm drains that allow the floodwaters to flow back out, but do not allow the seawater to flow in.
These metal cages filled with rocks are a low-cost alternative to seawalls called gabions. Here, homeowners have protected their properties by building these lower-cost ad hoc defences.
Hard engineering coastal defences like this are very effective. Even in the largest winter storms, it's very unlikely that any waves will get past this sea wall. However, this kind of engineering damages the natural landscape and habitat, and it's also very expensive.
With rock armour costing between £1,350 and £6,000 per metre, and sea walls costing between £700 and £5,400 per metre, depending on the complexity of design and construction.
So where possible, it's important to carefully manage the natural protection provided by beaches, sand dunes and wetlands to avoid the need for this kind of hard engineering.